Welcome to the Real Python Podcast. This is episode 178. How do you prepare a scientific Python project for sharing with others? Could you use some best practices and guidance for packaging, documentation, and testing? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's weekly articles and projects. We talk about the creation of the Scientific Python Development Guide. The guide was finalized during the 2023 Scientific Python Developer Summit and is a resource for modern packaging. It includes sections of tutorials, principles, templates, and common patterns. Christopher shares a recent Real Python tutorial about sorting Unicode strings in Python. He covers some of the pitfalls and how to avoid them. The tutorial includes multiple third-party libraries to assist in wrangling Unicode characters. We also share several other articles and projects from the Python community, including a couple of release announcements, namespaces and variable scope in Python, benchmark comparisons of Numba and Mojo, a discussion of recent AI fails, a TUI for log files with a merged timeline, a cross-platform GUI building tool similar to HyperCard, and a project for reproducing exact argparse arguments. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hi there.
We have a bunch of stories this week for you and topics and things to cover. A kind of a short discussion of recent things that we found in the news about AI and LLM stuff. And I'm going to do the news actually this time, which is a nice change, I guess.
Is for me.
Yeah, exactly.
It's Mr. Trudeau's lazy week. Go for it.
Yeah, there we go.
I'll just sit back and mock. How's that?
That sounds good. Yeah, just lob them as you go. All right, so to start with the news, Python 3.12 just came out. We had a big episode about it. You probably are aware if you're in the feed and following along. Well, they've already released 3.13 Alpha 1. And it's the first of 7 planned alpha releases for Python 3.13. Many of the new features are still being planned and written, and you can follow us because we always mention many of the PEPs that are planned on being implemented in it. So as an alpha release, it's kind of doesn't have a whole bunch in it, but I'll include the link and you can dig in a little bit more. One of the notable changes so far, deprecations and probably deprecation warnings. There's a bunch of them that are scheduled for removal in 3.15 or 3.16. And so again, link to read a little more. Kind of on a related note, there was a core sprint that happened over the last couple of weeks, or at least a week ago in Brno in the Czech Republic. And Łukasz Laga and Pablo Galindo, they started a podcast. It's called core.py, and they talk about the alpha release thing I just mentioned and the core sprint. So if you're interested, I'll include a link to it. And I mentioned to them that if they wanted to come on the show and talk a little more about what they plan to cover on there, they're welcome to come on the show. Speaking of PEPs, this is a recent PEP 730, and this one is authored by previous guest, Russell Keith McGee, who's been on a few times to talk about Beware and continued development of that and the briefcase format of trying to get Python on as many platforms as possible. So I found this one really fascinating. The title is Adding iOS as a Supported Platform. The PEP proposes adding iOS as a supported platform in CPython, and the initial goal is to get Tier 3 support in Python 3.13, so the one we were just talking about. If you haven't read a PEP, this is a good one. You can dig into it and you can kind of see the structure of it. It describes the technical aspects of the changes that are required to support iOS and describes the project management concerns related to adoption of iOS as a Tier 3 platform. And then as you read through, there's like a motivation section, which reiterates something that I've mentioned multiple times and talked to Russell about on the show, is that importance of mobile platforms for computing and how many people have them and people walking around with them every day in their hands. And the idea of getting Python on them is, in a way, as important as getting it on the web in some ways. So, and iOS is a big player in this space. The PEP digs into many of these other technical details, including comparisons to the work that's being done with WASI and Emscripten, and the work that Beware has already done to get things published on iOS already. The last piece of news I have is about Mojo, and we covered Mojo a few times on the show. Most recently, we talked about the local download for Linux systems that was back in September. And a lot of people were clamoring and saying, hey, when's it going to come out for other platforms or specifically for the Mac? Well, Mojo is now available on Mac, specifically Apple Silicon, which I think is probably forward thinking on their part, considering that Apple isn't going to make any Intel-based computers in the future. There's a pretty detailed blog post that features the steps to get started with the Mojo SDK. There's also Visual Studio Code extension for the Mojo SDK, and there's a video that they share in that post about giving an overview of using the Visual Studio extension. So there's your news. All right. I'll have to create a good fade out for that.
Good job.
All right. So what's your first topic here, Chris?
So I'm starting out with a real Python article called How to Sort Unicode Strings Alphabetically in Python. It's by Bartosz Sajinsky, frequent contributor. And as we've come to expect with his stuff, it's a very deep dive. Although the title implies something kind of simple, if you've ever messed with Unicode, well, you'll know there is never, ever, ever anything simple about it. Language and the characters that represent it is kind of messy. To highlight this, early in the article, there's an example which shows the sorting of words in French. So if you consider the same set of letters, some with accents and some without, how do you sort that? How do you sort a word with an accent? Well, and then you've got the additional question of, well, what if it's got two different kinds of accents and what order do they go into? And if that doesn't sound messy enough, let's add the fact that the answer to that question depends on where you are. The sorting for Canadian French and French has different rules. So the same word in the same language ends up with a different sorting order because of the locale. So messy, right?
Yeah.
To be clear, this isn't a Python-specific thing. It's something you encounter anywhere that you're going to process strings with Unicode. This is based on something called the Unicode Technical Standard, which specifies, amongst other things, a hierarchy of weights for a character. And that weight thing includes things like the starting base letter, any accents on that letter, whether it's upper or lower case, and then finally the rather unspecific sounding other features. So there's like a catch-all on it as well. And this weighting is called the Unicode Collation Algorithm, or UCA for short. And mucking with this isn't actually built into Python's standard library, but there is a third-party library called PyUCA, although pronouncing it PyUCA sounds like more fun. The library is kind of dated and only has an older version of Unicode built in, but it does allow you to download data that specs out the latest version. This data is called the Default Unicode Collation Element Table, or DUSET. I'm going to go with a soft C. C language is complicated, even pronouncing things. So if you've got an up-to-date version of DUSET loaded into PyUCA, see, I told you fun, you can get a tuple specifying all those weights that I was just talking about for any letter or for any string. And then, of course, because you can compare tuples, you then can compare these two tuples for two different strings and determine the sorting order that applies. The function for determining this tuple in PyUCA is called sortKey, and as it returns a tuple, which is a comparable value, you can pass it in as a reference to the actual sort function, and therefore you can use PyUCA to tell sort in Python how to actually sort these kinds of strings with sort of the standard library. Underneath, the PyUka library is limited. First, as I mentioned, it's kind of out of date. And second, it doesn't allow you to actually control the rules. So if you wanted to mess with this, you'd have to actually customize the doset file yourself to make changes. There is a alternative, though, which is PyICU, which is a Python wrapper to the open source International Components for Unicode library. Unfortunately, it is just a wrapper. It doesn't ship with the underlying code. So you need to have an existing compiled version of the ICU, or you've got to go off and compile it yourself, which means installation here is a bit of a process. You can't just pip install the thing.
Yeah.
So if you do want to go down this path, it supports customization. So you can read in doset files and then say, hey, we're going to change this or change that and play with it if this is what you want to do. The article is divided into 6 sections, and although I've been yammering for a little while now, all I've talked about is section 1. So like I said, this is a deep dive.
Yeah.
It goes on to talk about how the locale module in Python impacts the processing of strings, how to transliterate non-Latin characters into their Latin equivalents, how to do case-insensitive sorting strings that contain numbers as if they're actually numbers, so that 10 comes after 9, for example, and how to sort complex objects like classes with multiple fields. So I'm not too sure whether to be happy or sad that an article this deep on Unicode got all the way through without mentioning the rejected request to include Klingon. But there's otherwise, not including that, there is lots to dig into here. So if you want to learn the ins and outs of Unicode, this one definitely peels the onion back a fair ways.
You have a really nice course on Real Python, video course, digging into Unicode and kind of the complexities therein. So I might include a link for that this week. People can dig into.
Yeah, Unicode to me is like regexes. It's one of those things I relearn every single time I have to play with it. I've got this mental abstraction that is incorrect, and then I go to do something with it, and I'm like, oh yeah, right. This is complicated. So
yeah, I need to dig into it again.
Yeah.
So my first article this week is by Mohammed Raza, and it's on his blog. The title is Python Variables, Namespaces, and Variable Scope. And it's a fairly short introduction to scope and namespaces. If you're interested and want to dig in a little bit further, I'll include some Real Python supplements that could go maybe along with it. Actually, one of them is a very good video course that is kind of a discussion with a nice tool being used that shows off really what these kind of namespaces sort of look like and when you're within the different scopes. As I said, it's an introduction to this idea that starts with a section just, what is a namespace? And generally, namespaces are like a container that hold the collection of identifiers, i.e. names. And, well, what are things that can be named? Well, as we talk about in Python all the time, everything's an object. So variables, functions, classes, and more, all these things are in memory. And there's this sort of dictionary built-in feature that allows you to have the name and whatever the values are attached to it. And if you haven't played around with the dir command, it's a way to kind of see what's happening with these different namespaces. He dives into the concept of uniqueness and avoiding ambiguity. The types of namespaces that you may have heard of is there's like a built-in namespace. These are Python's built-in functions, exceptions. When you start Python's interpreter, it builds up that built-in namespace. There's a global module-based namespace. It's specific to the script that you're running or the module that you have currently loaded. It's created when the module is imported or the script's run. And then there's an enclosing namespace, sort of function namespace exists for nesting of functions. So if you have a function that has another function inside of it, there's this concept of an enclosing namespace. It sort of allows you to chain multiple functions inside of each other. And then inside, when a function is actually called, there's a local namespace for it. And so once the function execution completes, that namespace actually sort of disappears. And you can kind of think of this sort of digging into these layers of the onion and kind of going in and out inside of these different namespaces. Similarly, there is a set of rules for variables and their scope. And they actually kind of go in, they're very often listed out in a reverse order called the LEGB rule. And L is the local, so that's the current function that's running. So variables that are created inside there only really exist inside that scope. So like if you have a function and you assign a new variable inside there, that's not accessible outside of that particular function. And so he talks about that. Again, there's an enclosing scope. That's this idea that beyond what local you were running, if there's a function that was above that, sort of enclosing that area. And then global, again, the sort of module level. So again, if you are writing a program and at the top of it, or let's say it's just a simple script, you have a variable, very often you might assign variables at the beginning of your script. And in that section, say, okay, name equals, and then you assign a particular variable, that would be global. And it's accessible inside the enclosing or a local scope, but kind of not in reverse. If you were to go into a local scope and create a new variable, and this can happen sometimes, and you try to reassign the value, that won't have made a change to the global value itself. So he kind of covers that, discusses it. This is a little hard to do without visuals, but he provides a handful of code examples showing off these scope levels and the potential problems that you'll get into not being aware of this idea and back and forth. The last level of variable scope is the built-in scope, which is, again, the built-in comes as you launch Python itself. So an article that dives in much deeper, this is a lay it on us joint. It's called Python Scope and the LEGB Rule, Resolving Names in Your Code. Is a nice, very thorough deep dive that, again, as Laodanis likes to do, gives you the basics. And then if you want to keep going, you can kind of continue and cover much, much more depth. The video course I was talking about that I really liked is called Exploring Scopes and Closures in Python. And this is by Martin Broyce. And he uses a tool. It's sort of like a IDE, but it's kind of more geared a little bit for beginners, but it has a unique feature. The tool is called Thonny. And one thing that you can do is that you can actually open up an editor inside of specific scopes, and it can show you all the current, it has a window on the bottom if you want that will actually show the current things that are in scope, the current variables and their values. It's really neat. And so I enjoyed his sort of exploring of scopes and kind of like what's happening inside there, and this idea of like how things are enclosed inside of each other as far as how you access them. So again, I'd like this as a nice introduction into it, and then there's a couple different paths for you if you want to dig in a little bit further.
Yeah, and this ties back into what we were talking about in the 312 episode a few weeks back.
Yeah.
That 312 has changed. They've optimized how list comprehensions work. And the list comprehensions themselves kind of have their own scope. And that was one of the complications in making that change, was they had to make sure that things didn't leak out of the comprehension into the local scope or into the global scope. So, yeah.
Yeah, I guess the immortal object is kind of maybe tangentially related too.
Yes, yeah, because the garbage collecting is based on when things go. You can't collect it until it's gone out of scope, so you have to understand whether or not it's in scope. Yeah, so it's those are all nice little callbacks for sure.
Cool. So your next one kind of digs a little further into Mojo. I guess I didn't really introduction like what Mojo is, but the idea is that it's a faster tool for doing. I mean, their goal is to do AI programming development, not necessarily a replacement for Python. What's your article get into?
So it's one of the Mojo's biggest claims has been they've been pushing hitting the performance drum over and over again. So it's compiled language, and why you would switch to Mojo from Python is really, and particularly in spaces like AI, it's because you got to bash the heck out of a whole bunch of data, and so performance is really, really important. So as Mojo's come out of beta and onto platforms, people are starting to play with it. And this article is by Maxim Saplin, and it's called Mojo Head-to-Head with Python and Numba. So Maxim basically tested the performance claims of Mojo, putting it against several variations of Python, trying to solve the same kind of problem and sort of see where things are. So let me just get something out of the way first. I have not played with Mojo at all. So my info pretty much comes from this article. And so as you know, and the language is still in flux. So there's a chance that anything I could say could be wrong because Maxim misunderstood it.
Yeah.
I misunderstood Maxim, or it may have changed. I'd bet on the second of those three choices. If there's someone to blame, it's probably me. But anyways,
well, it's a moving target, regardless.
Very kind, yes. So the first hurdle Maxim ran into is a bit of a PR one. We were talking about this just before we went on the air. The folks at Mojo keep talking about it being Python-like or Python-inspired. Well, there's like, and then there's like. You can't just start writing Python in a .mojo file. It isn't going to work. It is a different programming language. Now, the syntax is similar enough to Python, and therefore for Python programmers, it's not that hard to pick up. But for example, you run into simple things like they use struct rather than class. And so it isn't just a copy and paste exercise. The second hurdle that Maxim talks about is there is currently a lack of arrays or lists built into Mojo. So in order to write the programs he was going to compare, he had to write his own. And that's actually how I figured out that they used the struct keyword instead, was from reading his Mojo implementation of a list. The third hurdle, and I think this would be the biggest difference for Python programmers, is Mojo uses a Rust-like memory management mechanism, which means there's no garbage collection. And this kind of makes sense if you're trying for performance, as garbage collection has this unfortunate habit of taking over the CPU when it feels like it. And that might be when you're trying to get something done. So I get why that choice was made, but it means your style of programming has to change a little bit. So the benchmark that Maxim decided to use was the generation of a Mandelbrot set. He implemented 4 different versions. So there's a baseline Python version, that same function, but wrapped with Numba. And Numba has a JIT decorator, which is just-in-time compilation. Then he also tried the baseline plus Numba's parallelism technique, which replaces the range function with prange, and essentially automatically gets you some concurrency. And then, of course, there's the Mojo version, because that's the whole purpose. So the base Python implementation took almost 11 seconds to run. So that's where we're starting. And just by turning on the Numba JIT decorator, got a 16 times performance improvement, knocking it down to 0.68 seconds. Every time I read something about Numba, I go, I got to go play with this, because I keep seeing such good things. I got to go. This is definitely on the to-do list. Numba's prange cuts that 0.68 seconds almost in half, bringing it down to 0.38 seconds. So just by mucking with a couple little parameters inside of Numba, you're getting huge performance improvements over the base Python. Now, of course, what you came here for was, what did Mojo do? Well, it delivered on its promise, and it ran in 0.32 seconds. So that's a whopping 34 times faster than the Python baseline, and slightly better than Numba with parallelism turned on. But wait, there's more. In running the benchmarks, he noticed that the sets produced by running the scripts weren't the same. So he was getting different numeric values depending on which program he ran. And this variation is coming from the fact that he's dealing with floats, and how Numba and Mojo and a couple different flags affect things, changes how floats are compared or rounded and whatever. So Numba has something called a fast math flag, and turning that on and off can actually result in different numeric answers. So this is one of those fun things that you always get into when you're playing with floats. And just when you thought it was all done, there's an epilogue to the article, and Numba comes in from behind in the epilogue. So one of Maxim's colleagues pointed out that his baseline version of the program uses NumPy, and Numba tends to optimize better without third-party libraries. So he built a new version without NumPy. And this to me is counterintuitive. I would have thought NumPy was the answer. And without NumPy and using Numba, it brought it down to 0.29 seconds, or just 0.19 using prange. So it's kicking Mojo's butt at this point in time. And then, just because that's not enough, there's an epilogue to the epilogue. And this one talks about how some of the computation was done. The calculation for Mandelbrot uses complex numbers, which have a real and an imaginary component. And so his Python and Mojo scripts both processed these as distinct numbers, essentially, and then combining them when they needed to be. And this is really an optimization. So he then went on instead to provide a class implementation of a complex number, and it seriously slows down the work. Now, this left me scratching my head a little bit, as complex numbers are built into Python, but not a lot of people know that. So I wasn't sure why he implemented the class. I'm not sure whether he didn't know that the complex numbers were there, or whether he was trying to achieve something else. But it does kind of leave you with the fact that there's like orders of magnitude difference with very few programming changes. And this is one of those things you always run into when you're dealing with performance, right? Your design choices can make a big, big difference. So there's some interesting things going on here with Mojo. The caveat is once you get down to optimization things like JIT, and I suspect you might get similar things out of PyPy, Mojo's not that far. It's not like it's leading the pack anywhere along the way. So then it becomes the question of, is it worth switching to just to gain that?
Yeah, I think some of the stuff with Mojo that's interesting, it has to do with the idea of the way architecture's changed also, taking advantage of, not running on a single machine, running on, GPUs and all this other kind of interesting ways that, you look at how code is being run today. So I don't know. I definitely, that's interesting. And it's funny that we ran into things that we've repeated recently, like, floats are potentially problematic.
Yeah.
And also trying to implement your own version of complex numbers is potentially problematic. It's very interesting.
And there's a big asterisk you can put beside all of this. Like the article doesn't talk about what his methodology was, right? As to how many times he ran the tests and that kind of thing.
Yeah.
I was curating for PyCoders this morning and ran across a 311 versus 312 performance comparison on like 90 different benchmarks. And the difference between which is faster depends on which processor you ran it on. So if you ran it on AMD, more than half of the benchmarks for 311 were faster. Whereas if you run it on Intel, more than half the benchmarks for 312 were faster. And that could just have been whatever Windows was doing in the background when this guy ran those scripts, or it could be that's the difference in how the processors, because there's a bunch of numeric computations, deal with that, and maybe they are faster, right? There's an awful lot of variables when you try to measure this stuff, and unless you're doing it over and over again and like pulling averages out of it, when the numbers are close to each other, you might see one win in one iteration and then lose in another.
Yeah. And I don't know. It's again one of these like, watch this space.
Yes, very much so. Yeah, very much so.
And I'm sure there's going to be lots of techniques that you develop as you go to for either of these types of tools. This week, I want to shine a spotlight on another Real Python video course. It's a different type of video course. Instead of being based upon one of our written tutorials, it's a conversation about code. And in this case, it's on a related topic to one of this week's stories: how scope works inside of Python, and what a closure is. The video course is titled Exploring Scopes and Closures in Python, and the instructor for this code conversation is previous guest Martin Broyce. And he takes you through clarifying code by refactoring with descriptive names, how functions access variables within local and non-local scopes, how inner and outer function calls access scopes, how to debug a project and its scope using the Thonny editor, and inspecting closures, dunder code, and cell objects. You also take a deep dive into the inner workings of Python by inspecting dunder objects to find out how Python handles and stores variables. Like most of the video courses on Real Python, the course is broken into easily consumable sections, and where needed, you'll get code examples for the techniques shown. And all our courses have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. Well, my next one, I got really interested in this because I feel that I've discussed this idea that even part of our discussion last time was that there are a lot of developers coming to Python that don't have a CS background and maybe don't have the sort of professional development skills. And a lot of that might be the scientific community. And they want to share their code. They want to share the things that they've created and share these tools between each other. And it's kind of an interesting subset of people. Like, it's a group of people that work very often with Python scripts in stuff that's in Jupyter notebooks. And that can become really unwieldy depending on how you're managing it. And that's hard to share that sort of stuff. The story and blog post is by Henry Schreiner. It's on the Scientific Python blog, which I think anybody who's doing data science or is interested in sort of hard science stuff really should check this out. I think it's a really great blog, has lots of really good information. They recently had the 2023 Scientific Python Developer Summit. It was held in Seattle at UW. So that was something this summer. And one of the goals they had was to create this thing called the Scientific Python Development Guide, which the tutorials start with, do you have a pile of scientific Python scripts or Jupyter notebooks that are becoming unwieldy? Are changes to some parts of your code accidentally breaking other parts of your code? Do you want a more maintainable, reusable, and shareable form? So they've built this guide and set of tools, including cookie cutter templates, a repository including all this stuff, and help with continuous integration, GitHub Actions, pre-commit checks, all these kinds of core developmental things that we've talked a lot about, and packaging kinds of things, and are sharing it with a guide and a tutorial and kind of walk you through these kinds of stuff. The guide was originally started by a group who's created something called scikit HAP. It's scikit-HEP. The S and the H and EP are all capitalized. The HEP is standing for high energy physics. And they had started it in 2020. And so they were able to use it as a nice sort of jumping off board from that. And I really liked the tutorial. It was kind of my best way to kind of get into a lot of the stuff that was there. It aims to help scientists who write code kind of find best practices and standardize their tools, and help people with small or medium-sized scientific software projects get started off on the right foot. And the table of contents digs into like introduction to development. And inside that, they're talking, okay, well, you need to isolate your environment. And they talk about creating virtual environments and doing that either with the types of tools that we often subscribe, or if you're dealing with Conda, how to do it with that, making sure that your documentation is in line, whole section on packaging, and then digging into much more stuff like testing and then overall writing documentation, and then patterns or recipes for common situations. I just think it's great. Many scientists who want to do development, they don't have this developer background. Their tool sets are really unique compared to general Python. And they're also, though, kind of similar within that community. And so like the idea of having a set of standards that could be used across the scientific community, I think is really cool. So I was just very excited about it. So I thought I'd share that. So I think that takes us into what we are deeming as a discussion, even though it's kind of just more like some recent stories that we found. Do you want me to start?
Yeah, go for it.
Okay. So this one I found somebody had shared on Mastodon, and the title of it is, "I'm banned for life from advertising on Meta because I teach Python." And it's by Reuven Lerner. Reuven has been on the show before. He came on to talk about generators, coroutines, and learning Python through exercises. And he's written a variety of books, but he's a trainer, of Python, and teaches pandas. A few years ago, he decided, well, he wanted to advertise his products, his books and his courses and his training. And so he ran a bunch of ads, and he didn't get a whole lot of return from it, but he also really didn't put a lot of effort into it, he says. So he said, all right, well, that campaign didn't work, but he was, advertising, hey, I train Python. I train, people to learn how to work with pandas and so forth. And it was a year or so ago that he thought, well, maybe I should do some advertising on Facebook, now Meta, and went to his advertising page and was surprised to find out his account had been suspended. And it said he had violated Meta's advertising rules. He checked around. He had people that worked at Meta that he had either taught or did training with or just made connections with, and reached out to them and tried to figure out what was going on. So he got an answer right away when he kind of finally checked in on LinkedIn with somebody. A friend of his also had problems advertising Python training courses on Meta platforms because Meta thought he was dealing with live animals, which is forbidden. So that idea of quote unquote training pythons and training pandas.
I want to know what they were training the pythons and pandas to do, and I want to know whether or not they were together. Like, was the python
exactly.
and the panda working together? Is this like a heist movie where the target is bamboo or something?
That's the Bad Guys movie. I think there's like a snake,
yes,
Mr. Snake,
exactly,
and Mr. Panda. All right, too funny. So it's sort of an AI gone awry kind of thing. He actually went through the steps to like, okay, well, let me do an appeal. And, that's not reviewed by a human being either. And it's like, nope, sorry. Definitely this fits this category. And the other problem is that he kind of waited a little long. And so sort of a well, sorry kind of thing. But yeah, it's pretty fascinating. I don't know if the story will change that for him. It's not like a huge platform for him to advertise on, but it's one of those just kind of goofy things where you're like, really? Like, I would bet that AI was trained using Python.
Yes.
It's like, don't you know yourself?
This is the world we're getting into, right? And there's perfect examples been kicking around Twitter and other places recently, which is somebody had typed in salmon spawning upstream in a generator, and the picture that came back was salmon steaks in water.
Yeah.
And I was actually working with teaching a course on AI for non-technical people earlier this week, and trying to get them when you're interacting with ChatGPT, you think it understands, and to show you that it actually doesn't. It's just a really, really advanced prediction mechanism.
Yeah.
And there isn't a lot of knowledge in there about the fact that one context this is steak, and in the other context this is fish. Because we're talking about swimming, well, maybe we should go with the, actual thing with the fins and the gills, right?
Yeah, steaks don't typically swim anymore.
and this stuff goes way, way back, right? So when I actually did a little bit of work in grad school in this space, and I remember hearing this story, and it's long enough ago that I have no attributions in it, so it may not even be true, but it kind of is representative, is guys I knew were working with circuit optimization. So when you're designing a circuit, you go into the CAD programs and you design what the circuit's supposed to do. And then there's a separate step for actually laying that out on a board. And so they were using genetic algorithms, which is this idea of you put like two versions in and then they fight, and whichever is better wins. And then you modify the winning one and you keep doing that until you get an actual solution. So they were running this.
Sort of like code Pokemon.
Essentially, yeah. That's the idea. And there's variations on how you do it and whether it's random and a whole bunch of other stuff. But the essential is it's creating an algorithm that is, survival of the fittest. And they were doing this for some board, and they got out an answer, and the circuit board that resulted had a chunk in the bottom right-hand corner of the board that was not connected to the rest of the board. And basic circuits is, if it's not connected, it doesn't do anything. So they're like, all right, fine. So they deleted it, and it stopped working. If they didn't include this piece that was not connected, the circuit wouldn't work. And so, of course, this is this big mystery, and they drilled down on it. And what it turns out is that the chunk in the bottom right-hand corner was changing the heat aspects of the board. It was making the board hotter, which was influencing how the other circuit that it wasn't connected to actually performed. And all of this is back to the fact that they didn't include temperature in their modeling. And so they had to actually go back, and in the future, they started to say, okay, not only does this circuit have to solve this problem for the GA, but you also have to include the fact that it has to operate in these kinds of temperature ranges. And this is the challenge you always have with AI, right? Like,
yeah,
you hear the stories about, this will be unbiased because there's no human, but then we're training it with biased data. And so all you've got is a computer that ruthlessly impacts using the bias it was trained with, right?
Yeah.
it doesn't understand that Panda is both a library and a fuzzy little thing, right? And so you end up with these kinds of challenges.
Potentially endangered animal.
Yeah, exactly. We are, I'd love to be wrong about this because it would change the world, but we are very, very far away from actual general AI, the talking to robots kind of thing we see in the movies. And every time this kind of technology becomes part of the social conversation, people who don't understand that immediately go, "Oh, this is great. I'm going to do these things with it," and then there are consequences. There's a story kicking around. Again, I haven't validated this yet, but we're starting to see ChatGPT generated books on places like Amazon.
Yeah.
And I've heard that there is one that is on how to pick mushrooms. And of course, we're talking about a tool that routinely lies or hallucinates or whatever else. And the fact that some mushrooms can make you very, very ill or even dead.
Yeah.
The fact that there's an AI generated version of this kicking out there, that there can be real consequences to this stuff.
Yeah, there's this author I really like, and she had actually posted on Mastodon saying, "Hey, do you think this is a ChatGPT review? Because I'm trying to figure out what's going on here." And she posted this link to Connect Savannah, which is like a news and arts entertainment magazine for Savannah, Georgia. Her name's Martha Wells. If I didn't say that, she had written a very popular series called the Murderbot Diaries, which is about AI in a way too, which is kind of interesting. And she also does fantasy books that are not sci-fi called The Witch Queen or Witch King. And so the review is for The Witch King, and it says, Martha Wells continues to captivate readers with Witch King, an enthralling installment in the Murderbot Diary series. And you go, uh-oh. The story follows Murderbot, a unique AI with human emotions and strong sense of independence, in Witch King Murderbot finds itself in a fantastical realm replete with ancient technology and formidable magic. Here it encounters a rogue AI and a power-hungry Witch King whose actions could destabilize the realm. As Murderbot navigates through the world of ethical quandaries, concealed conspiracies, and a quest for justice, Wells blends elements of science fiction and fantasy, create an absorbing narrative. Anyway, so this is completely just made up. And I was trying to think how it thought about the Murderbot Diaries, and then I'm guessing it went to look about the author and maybe made that connection. The eagerness is the weird thing that I have about a lot of these systems. This eagerness to make these kind of leaps I hate the word hallucinations because I think that's kind of dumb. I think it's more like just bullshitification, honestly. Yeah, because I've had a couple experiences in trying to do summarizations of stuff. One of the features I had used in an earlier version of ChatGPT was to be able to not have to copy wholesale an entire, let's say I'm summarizing a article I was going to talk about or whatever. And, copying and pasting that into the window seems kind of redundant. This thing is online already. I should be able to just put in a link. And I had done that a few times. And then recently I tried it again. And for whatever reason, it could only grab just portions of the article. And so it would have the name right and maybe the title of the article. And then it just completely, just eagerly made up the rest of it. And I was like, why? When I copied the actual text into it, it didn't do that. And so I would rather get a 404 or some, kind of some error, saying I couldn't access that information, than it just to kind of just eagerly just bullshit me. So that's something that I'm wondering if the programmers who are creating these tools should look at.
Part of it is also what is the purpose, right? So if you were trying to write a tool that did nothing but summary, you'd probably take a different approach than what they've done here.
Yeah.
And so you would have NLP processing and then have it work on nothing but the article, and then it couldn't hallucinate or whatever else you want to call it.
Right.
Whereas ChatGPT really is text prediction. And so what ends up happening is, your article talks about pandas. And it says, oh, okay, pandas is associated with NumPy. And although your article never mentioned NumPy at all, it might start talking about NumPy because frequently those two terms are found together in articles on the internet, right?
Right. I've seen the relationships.
So this is where it's going off. And that's a reasonable conclusion in a certain extent. And then you've got the other problem of distinguishing between, the numeric processing library and the fuzzy little guys with the cute faces, right?
Right.
That there's a technical tool called Bamboo, which is just going to confuse it all that much more, right? So, again, this is that sort of association problem, and what kind of tool are you using?
I mentioned this when I talked to Al Swigert about LLMs, and when you give it really super detailed instructions, like things that are kind of tedious for a human to do, things like formatting and following very, very specific layout types of rules, I think, if you can get the instructions detailed enough, I'm impressed with the results there. It's figuring out like the eagerness sort of stuff and, getting reasoning back from it. And I don't know if that's something they would ever plan on sharing or not. I don't know if that's like revealing too much about how the model's been programmed or...
Well, and the other aspect of it too is these are things that adapt, right? So there's an article I came across a few weeks back where somebody had taken, I think it was 60 different LLMs and asked every one of them the same 20 questions, and then massive amount of data as to how each one answered and what the patterns were and all the rest of that. And you could see how certain things worked better than others, right? So when you asked most of them to answer in a haiku, most of them could do that, and you'd get haikus back, which is all very clever, but
right.
The haikus often had incorrect information in them. So it's a neat party trick that you're programming answers in a haiku, but if it's telling you something that's not there. One of the pieces he gave was a very, very simple little brain teaser that required you to understand the fact that if I have a sister, the number of brothers she has is, that you can't double count me is what it comes down to, right? That sort of family relationship. And every single one of the LLMs got it wrong. They just multiplied the numbers together and got the incorrect answer.
Yeah.
And then within a couple of days on Hacker News, people were pointing out that, hey, wait, ChatGPT-4 is getting it right. And it wasn't before. So, and the only reason that's going to start working, these are not logic machines, they're text predicting machines. So someone has started feeding that problem or those kinds of problems into the model. So just because it starts to be able to answer that brain teaser correctly doesn't mean it now understands how to do brain teasers, right? And the place we are, and I think the challenge as we try to figure out how to use these tools and how not to use these tools is the misunderstanding that people have about how it works or doesn't work. And this is what kind of happened, with the AI winters in the past. People looked at it and went, oh, well, like everything's moving so quickly. This is going to solve all these problems. And, I came across this quote from the 1960s, which was we were going to have artificial general intelligence by 1985. Well, yeah, that in our jetpacks, right?
Right.
And that's not to throw out all this progress. And there's interesting things in here, and we'll see, what works and what doesn't work. And once I think we start seeing real use of these tools, we'll be better placed to figure out, what it can do, what it can't do, and what's going to get some random lawyer fired. Shall we move on to projects?
Yeah. What's your first one here?
Sure. So I'm going to do two this time. My first one is called logmerger, and it's built by Paul McGuire. One of the wonderful consequences of textual being out there, that fantastic little library, is now we're starting to see some really neat TUI tools out here.
Yeah.
And this is one of them. So logmerger is a log viewing tool that can handle more than one log file at a time. And as the name implies, it merges them together. And it does this based on the date timestamp. So you can see the order of the events that happened from separate logs all in one place. The TUI's got multiple columns, one for the timestamp and one for each log file that's being merged. It handles multi-line entries. So if you've got like an exception stack or something, it knows how to associate that with the actual timestamp. You can skip to a line, or you can enter a timestamp and it'll go to the closest entry. And of course, because it needs to. It supports both dark and light mode, as well as searching for text. You can also run it in a non-interactive mode, so you can have it just output a merged content to the screen or to a CSV file. So it's a neat little thing. Handles regular sort of log text files, the kind of thing you see off a web server. It can also handle gzipped files. It can handle certain kinds of CSVs, and there's experimental support for PCAP files as well. So it understands about, I think it was 9 or 10 different timestamp formats. So you're pretty much covered for the most of the kinds of logs that I've seen this tool is going to be able to read. Very cool, very usable. I have a couple feature requests if Paul happens to be listening. The columns should be optional. I understand why he went with columns, but when you're trying to compare more than 2 files, you start getting like 3 or 4 columns. It starts to get messy. It would be nice to be able to switch back and forth between like a column and a row. Would be kind of neat.
Kind of a layout issue.
Yeah, just a layout thing, yeah. And then the other thing would be the ability to go to a timestamp is very, very cool. But I'd love to be able to see something like go ahead by 3 hours or a day or a week or whatever. Because I know when I'm looking for something, it's often that like, okay, it's not here, it's the next spot, but I might not know how to type in an exact thing. So anyways, just a couple ideas. Feature requests aside, the tool solves a big problem and does it very, very elegantly. So if you're ever in the situation where you're dealing with multiple logs, this is definitely, you should add to your tool chest.
Cool. All right. Well, mine this week is called CardStock, a cross-platform GUI building tool. And I think I already asked you this question, but I'll ask it again. Did you ever mess with HyperCard, Chris?
Not directly, no.
Okay. Yeah. My time with Mac computers is just after their popularity, about the time that Steve Jobs kind of came back. And this particular project is by Ben Levitt, and it's mostly Python, and you actually create the cards with Python. But the concept of HyperCard is that you build these sort of graphical programs made up of individual cards, kind of like pages. And the hyper in it is, again, very similar to the idea of hypertext and linking things together. So in the case of CardStock and HyperCard, you build stacks of the cards that are the whole program, and the stacks then kind of are linked together and draw together and so forth. You get this sort of drawing program like editor for building a graphical user interface. So I've seen examples of like little simple games, even like an asteroids game or of course, Pong and things like that, or, creating like a calculator with it. And a lot of those are single card kind of things that are built in there. But what I thought maybe would be really cool with it is that it is a way that somebody could learn Python basics. And so they have a whole tutorial that goes into using CardStock as a way to do like kind of a crash course in learning Python. And so I'll include a link for that too. To run it from source, if you want to really dig into it, it uses WX Python. So you would sort of pip install WX Python, PyInstaller. So you can basically make a finished version that can be running on Windows or Mac. It uses simple audio and then requests. But there's a pre-built application already, CardStock ready to go, that you basically are in the editor and building in it. And then, as you're creating stuff in like a list left window, which is your graphical section on the right-hand side, you are writing your Python and kind of structuring stuff together. You get this editor and the player and then also an installer. There's a set of examples online. And if you want, not only can you do like kind of the PyInstaller thing, but you can also share your work and run it online in this thing, cardstock.run, which is a website. HyperCard's like 30 years ago was this really interesting thing that kind of somewhat predates the web and still uses a lot of these ideas of connecting lots of different media together to create programs. And it's very, very visual. It's very, very hands-on in a way, the way that the cards are kind of organized. There's a game called Myst that was very, very popular, MYST, that was built using HyperCard. A lot of interactive edutainment of the era was, built using HyperCard. And, I've spoken to many people that have fond memories of using it. And this is a pretty neat implementation. And again, the fact that it's using Python as the tool with it, I think is kind of a fun project. I'll include a link to an Ars Technica piece called 30 plus years of HyperCard, the missing link to the web, that kind of gives you a little idea of some of the history behind HyperCard. But yeah, CardStock it's a neat project. So what's the second one you got?
The second one is an odd little toolkit out of the Sandia labs in the US. It's called reverse argparse, and its purpose is to output what arguments were used when a script was called.
Okay.
And at first glance, you're going to be like, wait, but I know what arguments were used. I typed them. But
Didn't I?
If you're trying to replicate the execution of a script, things like the defaults can matter. And so the motivation behind this tool is so that one user can give another user the exact command line arguments needed to run the same code they did.
Okay.
So it's all about replicability here. So consider a situation where you've changed one of the default arguments in your code. Well, an older script that calls your newer command might now start working differently because you didn't actually give that command line argument in the old script because you assumed the default was there. So by using reverse argparse, you see exactly all the arguments, even the ones the user didn't provide, that argparse passed to your program. So it's a bit of a niche, but it's interesting. And the good news is it's really, really simple to use. You essentially just import their library and build a class based on the actual argparse parser and the arguments that got parsed. And you call one method and it outputs the exact command line that was needed, including all the defaults.
Okay.
So I could see this being really, really useful for things like logging. So rather than creating a logging statement manually, you can just call the library, making for a nice clear, hey, this is how the program started log message. And of course, you could view such a log with logmerger. So, hey, call back for the win.
There you go.
So, yeah, as I said, it's a bit of a weird little corner, but I can see that there's places where this could be interesting. And if you're struggling with this kind of problem, this is worth checking out.
Nice. Well, thanks again for bringing all these articles and projects this week, Christopher.
Always fun.
All right. Talk to you soon. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.